She's recording it now.
I am now recording, so now we can only say things that are reasonable. All right, so let's take a look at what this one will look like. Guys, this one is the one that makes sense, because a lot of times when they charge us money, they round stuff up. They round up. Like if you hire somebody to come, a plumber to come to your house, they'll round their time up to the next hour. When you go to a parking deck downtown and you park in the deck for 2 hours and 3 minutes, they're going to round it up to charge you more money. So in reality, rounding up happens more often than rounding down. All right, so rounding up, if we do the same thing we did yesterday, 0 is 0 because it's an integer. But if I go 0.1, it's going to go up to 1. If I did 0.3, it's going to go up to 1. So this is like we talked about yesterday. 0.6 goes up to 1. 0.9 would go up to 1. So with rounding up, everything goes up. So what happens is, I'd have this point right here at 0, 0, but everything after this 0, 0 gets rounded up to 1 until I get to 1. 1 is 1, but then immediately after 1, I go up to 2. Everything just past 1 will round up to 2. And I'm good until I get to 2. 2 is 2. But immediately after 2, it's going to round up to 3. I mean, immediately. 0.2.0000001. We'll round to 3 if we're rounding up. Okay? So do you notice our barbell looks backwards? It does. A barbell looks like this. Okay, but we always start with this part of the barbell. You start with the solid. That's what you shift. So what we have to do is, with the parent graph, there's no shifting. So did the solid one start at 0, 0? Yeah. So we have to go back to open. So with rounding up, the very same idea. You still start with the solid, but we have to go back to the open. So we get our same little barbell, but our closed is in a different spot. We start with the closed, we go back to the open. Versus this one, we started with the closed and we went over to the right to the open. See the difference?
So it's just opposite.
It is just opposite.
So
Every single other thing works the same way. We just have to start with this part and go back. And then if you want to jump up and do an open over to closed, open over to closed, open over to closed, that's fine. But the first one you do, you start with the solid and go back to the open. Got it? Okay, so what we're going to look at today is, I'm going to give you a few minutes to work on two little, you know what, we'll do them together. I think that'll go faster. We'll do the first one together. I'll let you do the second one on your own. These are applications. The first one is about taxes. And this does make sense because the smallest amount of money that we deal with here in the U.S. is what? A penny. Okay? But our tax rate is what?
6%.
7%. Okay, so does everything work out perfectly?
No.
No, it doesn't.
I love taxes.
So, you love taxes?
I love doing this stuff.
Okay.
I hate taxes.
I was going to say, I've never heard anybody everybody say, I love taxes.
Oh,
I was like, wow, what an American.
I don't have one. No, I didn't.
All right, so let's take a look at this. All right, so you are selling candy bars. The taxable amounts and the tax imposed up to $1 a stone. So for amounts between 1 penny and 20 cents, the tax is a penny. For amounts greater than 20 cents and less than or equal to 40 cents, the tax is 2 cents. And then it keeps going. So it says complete the graph. All right, now when we do this, we have an open circle on 0. Because if we buy nothing, we're lucky. We don't have to pay any tax. Does that make sense? Okay? But the tax from everything from here to here, open circle at 0, from here past that is going to be a penny. What does that little bar look like? Does it look like the rounding up we just talked about?
Yep.
Okay, and then the next statement says, greater than 20 and less than or equal to 40 is 2 cents. So at 20, it's an open circle. But as soon as we go past 20, all the way over to 40, I didn't line that up well. There we go. It's 2 cents. Okay, take a moment and see if you can finish that graph. All right, does yours look like mine?
Yep.
Okay, so we have a couple of questions. Honestly, with any of these questions, there's no way I would think of a step function. It just makes sense. Tax just makes sense to me because I've been charged tax since I started buying lollipops when I was a little girl. Single-sided lollipops. All right, so a candy bar costs 55 cents. That's a really good deal for a candy bar these days. All right, so 55 cents would be right here. So if I went and looked at it'd be about right there. What tax rate is that? What would my tax be? 3 cents, okay? So that first question down there, my tax would be 3 cents. So you could write it like that, or we could write it like this, right? These two things mean the same thing. Okay? So if I bought a single candy bar, it would be, I'd have to have 58 cents to do that, right? 55 cents for the bar and 3 cents for the tax. All right, so number 2, your aunt buys you 3 candy bars. What a nice aunt. So what would we do? Three times 58. I was pretty sure you know that. Everybody knows that?
Yeah.
Yeah. What is that, 174?
It was having
174. All right, the last question. Someone purchases 4 candy bars at 55 cents a piece. They give you $2.25. Is this enough money to cover the candy bars and the tax?
Find out. Yes.
Yes.
It is.
4 candy bars. 4.
No, it is not.
How much would that be? $2.
$2.32.
Oh yeah. I read it wrong.
Okay. So, $2.32. They are 7 cents shy. They just missed it. Only 3 candy bars for them. All right, on the back we have another example. This example involves postage. So it says step functions are widely used in everyday life. We just don't realize they are, especially in the world of business. Pretty much any time we're charged for things, and it goes into this, gas, electric, water are often billed according to a step function. So our taxes, we have our different tax brackets, don't we? Try graphing this one. So here we have different rates and prices for postage. So along the horizontal axis, you'll put the weight. And along the vertical axis, we'll put the postage. And let's see if you can sketch a graph.
So, weight is on what axis?
The x-axis.
Yeah. I'm going to put a break in my graph. Are you guys going to? What are you considering counting by? 20 cents?
25 cents.
25? All right. Might be a little crowded. All right, can anything weigh nothing? No, if it weighs nothing, it doesn't really exist, right? So we got to have an open circle right here on a weight of 0. And so that would go, it's $1.22, $1.22 up to 1 ounce. That's my first little step. And then after 1 ounce, let's say it's 1.1 ounces, they're going to charge us for 2, because this is weight that is not over this. So as soon as we go over, it bumps us up to the next. So the next one will be $1.39. Then the next one will be $1.56. Does that make sense?
You have 10 minutes of class left, by the way.
Thank you. All right, so this is a rounding up function, right? And we talked about, we start with this one right here. So one way we could write an equation for this is that if we shift it to the right one, it would go up to, what is this y value? 122. And then what am I increasing by every time? How am I jumping up every time? Was it consistent?
Yeah.
Yeah, what is it? 0.17. And there's an equation. All right, down at the bottom of the page, I blew it. I wrote these notes and messed up just about everything. So, we got to make some corrections. We're going to fix
Can you
this.
go back to?
I can, just a second. Okay, so some of this is right. Rounding down can be named a greatest integer, floor, or in general as a step function. Does your worksheet say floor right there? No, it doesn't. I messed up. Please correct that. Scratch out ceiling and write floor, because that's what it is. And then I wrote rounding down again instead of rounding up. And then this should say ceiling. And then I didn't spell symbols right. I'm pretty sure I would have had to work hard to mess that up anymore. Alright, so this is correct though. Our symbols that mean rounding down, double brackets, single brackets, or this floor where it's just at the bottom. Rounding up, our only rounding up is where it's just at the top. Okay? So tonight's homework is practice with the rounding up and down mixed together.